Hello, and welcome to the introduction to SIG Cluster Lifecycle. For those of you who do not know who we are, my name is Tim St. Clair. I'm one of the co-leads for SIG Cluster Lifecycle. I'm also a steering committee member. I've been around the project since the beginning of time. So it's like dog years is Kubernetes years. So the project's like going on 5 years old. So I think I'm like 35 or something in Kubernetes landscape. And
I'm Lucas, the other SIG lead, and we have a third, which is Justin in Santa Barbara. I'm also a CNCF ambassador and, well, contracting for WeWorks.
So what is SIG Cluster Lifecycle? A SIG Cluster Lifecycle houses a series of subprojects. It's almost like an umbrella, which has a large set of different tools which are composable in a certain fashion, but it houses a number of different projects, and some of those compete with one another. So we have like over 600 members on the mailing list. There's 2,000 people on Slack and just our Slack channel. They're comprised of well over 20 companies now, especially with the recent incantations of Cluster API. On 5 different continents that we know of. There might be somebody in Antarctica. We're just waiting to see if someone down at IceCube is hacking away. Every cycle, we have in the order of thousands of commits from just our SIG alone. And currently we have over 15 sponsored SIG subprojects. So the mission of SIG Cluster Lifecycle is to simplify the creation, configuration, upgrade, downgrade, and tear down of Kubernetes clusters and their components. And it's a very loaded statement, which actually has many pieces to it, right?
Right. So we're doing these things, and like also other things we tend to say is like we want to scale it from that it should work well on one machine, but also like it shouldn't break when we're doing the second or the third or the 100 or the 1,000 machine. That's like a goal. We want to do this because if we don't want to end up in a situation where the only way you can run Kubernetes, it's so complex that the only way that you can run Kubernetes is by like spending thousands of dollars to some company that have figured it out. Then we will kind of collapse under its own weight with complexity. So instead we want to commoditize the different aspects of it. So we build utilities for various tasks, like kubeadm, which we'll get into later, so that everybody has a chance to use it, to experiment, and also to unify the different efforts. You've seen the CNCF certified, whatever, like solutions, I don't know, partners, what is it called? Like
Certified Kubernetes distributions.
Distributions, that was the word, yeah. The distributions, there's like 90 of them, so all of them needs to do pretty much the same things. Is there any way we could find some unity between these tools? And does everybody have to write like thousands and thousands of lines of code just to make Kubernetes up and running? Anything to add to that?
And we also want to get even a step further. So there's the idea of making one cluster easier to install, and then you want to take one step back even more. And what we find from surveys in the wild, we did a survey on the 113 release, and I'll get to that a little bit later, where we find that most people don't have one cluster. They have, on average, about 5. Some people are crazy pants. Larger distributions deployments have in the order of 200. Some have thousands. So the question is not only how do we scale the distribution and deployment of a cluster on a single set of nodes, but how do we manage that across tens to hundreds to thousands of clusters? Because the idea of spreading Kubernetes far and wide is it raises all boats, like Lucas mentioned earlier. So if we can do that, it becomes ubiquitous, right? You kind of take away the notion of distribution A and distribution B, because that has the tragedy of the commons, right? So when people differentiate on how to stand up a cluster, that basically it takes away from the core of the technology that we are all trying to bet our farm on for the next generation of abstraction layers. So by spreading it wide, making it ubiquitous, making it secure, it raises all boats. Everybody benefits from it.
Yeah, exactly. So the competition should happen above where you have Kubernetes, the Kubernetes cluster, it should happen in the next arena.
First and foremost, too, when we design our sub-projects, we also almost strictly adhere to sort of Unix philosophy. Make one program, make it do one thing, and do it well. And where possible, make sure everything is composable and separable. So some projects have multiple phases, and we try to make sure that each one of those things are consumable as individual components or pieces.
Right, so we have loads of different, as was mentioned, loads of different parts of this SIG. Is very huge. If we, yeah, I could, thanks. If we start with the cluster provisioners, these are the projects you might have heard of first, like COPS, or I think we have kubeadm too,
Yeah,
the
KubeSpray.
Minikube, KubeSpray, so on and so forth. So we have all of these, but now we want to find some unity between these. So we created kubeadm, which was the first project for us, where we're going to have another better picture of that, but take the common functionality that's needed from where you are at the level where you have a machine, you have some kind of infrastructure to run on, some compute, to where you have a conformant Kubernetes cluster. That's where kubeadm gets you, but nothing more, nothing less. But that also has some sub-pieces, like kubeadm does different things to set up etcd, which could also be done in a generic way if you do etcd something for Kubernetes specifically, but still. So that's why we're creating an etcd ADM, which is particularly focused on creating HA clusters that work well with Kubernetes, serving Kubernetes API server. Then we're trying to figure out cluster add-ons. We have a few in kubeadm built in today, but which are core DNS and kubeproxy, which are applied as manifest on top, just to get the conformant, make it a conformant cluster. But we want to find a unified story for that too. Like, is there any way we could declare that this is an add-on? But first, like, we need to, what is a Kubernetes add-on? We haven't got even so far yet. We started this effort really lately. Cluster API.
Yeah, and Cluster API is meant to, and I'll get to a slide later, is meant to answer the question of what happens when I want, kubeadm answers the story of when I already have machines, but what if I need to stand up all this extra infrastructure, and how would I provide an abstraction layer to do that and manage it across n different clusters?
And lastly, along the y-axis, we have loads of configuration for each of these components. So first we have, like, 5 components that are more or less core, plus all the extensions to Kubernetes, plus the tools we're building, kubeadm, etcd, ADM, different add-ons, cluster API itself. All these need configuration, so we're it's inevitable that we also focus on how to configure these things declaratively, not with flags.
Yeah. Who's, just by a show of hands real quick, who's actually taken a look at the command line flags for the API server? Just the sheer number. What's the average number you see? It's on the order of hundreds. Like, that's 100 different knobs to tweak. So it's like a NASA space shuttle, right? Trying to, like, actually get things configured properly if you really want to use some advanced features of the API server. So in my perspective as a maintainer who's worked on the project for a long time, this is a core fundamental problem. If people want to get engaged, I think that is a high value target with lots and lots of work to be done, right? One of the core values of the project is that you make your space by chopping wood and carrying water. This is a core example of, if you want to get involved in the community, we would love for folks to chop wood and carry water, to break the knobs and simplify the configuration space of Kubernetes.
Refactor things to make it simpler, to make it easier for everybody, although it needs loads of manual work and like...
Yeah. It's going to be a lot of work.
Yeah, hard discussions too.
It's an easy way to earn your stripes. So we talked about some of the key sub-projects, but we'll go into a little more detail. So kubeadm recently went GA. Like Lucas mentioned, it's a way to stand up a best practices cluster. It went GA in version 1.13. The user experience should be simple and reasonably secure. So security is a tough nut, I'm not going to lie. There's people who have layers of tinfoil hats, and to try and satisfy all those different layers, nothing would work. You'd be locked in a box and nothing would actually function. So we try to be as reasonably secure as possible, and every time we go through a cycle, like in 1.16, we're going to do a full security audit. So in the next cycle, if you are one of those people who likes to wear tinfoil hats, we'd definitely welcome your involvement in doing our security audit.
And I can add to that, so reasonably secure, we mean that, for example, well, how many of you are familiar with kubeadm somewhat? Okay, cool. So for those who aren't, when you first set up the control plane, you run kubeadm init. Kubeadm init will output a token, which is 22 chars, random chars, that you then paste into kubeadm join on the other nodes. And this 22 char token is secure, like it's pretty secure. It's like there's a pretty small chance that somebody comes up with exactly this random char string, but it's still possible. It's more secure if you have a certificate with like thousands of bytes. But still, it's like a fair trade-off. So that is what we mean with reasonably secure.
Yeah. So the balance there is user experience, right? Yes. We want it to be simple. Like we want to democratize Kubernetes as much as possible, and you always have this balance between usability and security. The more secure you make it, usually it's very difficult to keep that user experience to be nice and simple and clean. kubeadm scope is limited. It's intended to be a building block. So when we originally created kubeadm, there were already a bunch of installers. Kops already existed, kubespray already existed, and so did you name a configuration management tool. There were about a dozen of them on GitHub that you could just search and find around. And there was always a set of common patterns that we saw about bootstrapping the control plane. So why not make a tool that just does that? Then all these other tools can use that tool. Right? It's just a common pattern of distilling down the common things that you see, making it ubiquitous, and then they leverage it. And we've been highly successful with that. So if you name all the core projects that are built atop of kubeadm are all in SIG Cluster Lifecycle 2. I think the only outlier is Kops now that still has their legacy system.
Yeah, they're on their way, but it takes time.
Yeah. You want to talk about these ones?
Yeah, so I already mentioned that kubeadm scope is limited in that we have defined points, and we have also defined scopes of what it can do. So it won't, like kubeadm won't randomly SSH into some random machine and do something else, like some infrastructure thing would do maybe. kubeadm only ever talks to the Kubernetes API once it's up, and in order to get it up, it creates some files on disk. Certificates, for example, there's loads of like, I think we have 10 at least, maybe 12 different certificates. Stefan Skimansky and David Eads had a really good talk here in the afternoon, earlier this afternoon, on how all the things that are needed for an API server, for example, to operate. So it does that, writing files to the system, posting things, changing things in the API. Then it actually doesn't care about how the kubelet is running. You can run that in a containerized or somewhere like in systemd. There's loads of other crazy projects that do different things. But as long as there is a kubelet, it's fine. And you get this automatically working with apt-get install kubeadm. So that's the UX part of it. And actually, we're not even choosing. So the network in Kubernetes is third party. So we're using the other CNCF project, CNI, Container Network Interface, which Kubernetes implements. Uses, but then something else implements it. So we have Flannel, Calico, KubeRouter, Cilium, like loads of them. So that's up to you to add to the cluster, which is a kubectl apply away. other things you have. Yes, we talked about the composable architecture. Like now when we have these building blocks, we can even split them into smaller building blocks. So if you don't need all the things kubeadm init is doing, you can actually just choose parts of it to match your organization's, whatever, PKI flow or something.
Yep. So it's really common nowadays, and I think a lot, even inside of Cluster API, a bunch of folks do customization around using custom phases inside of kubeadm.
Right, so that's when we add all the things together, it starts to look something like that. Regardless of what infrastructure we have, whether it's like Google or Amazon or like my Raspberry Pis at home, we have some kind of compute. And here we're trying to find consistency through the Cluster API. We'll dive into that just in a moment. Then we have kubeadm, takes us from the machines to Kubernetes, and then we have operators on top of that. And as Tim said, we already when we started kubeadm, there were all these tools already. So like, why would you do it? But now kubeadm is part of every tool. It's not the full thing you need, but it's the common piece of everything.
So after the 1.13 release of GA, we did a survey. And the general survey was that the usability was really good. So that was interesting and good. And the common feedback we have was that high availability deployments and ease of use of high availability deployments was the most common thing that people requested. And later on tomorrow, there's going to be a talk by Lubomir, which is somewhere here, and Fabrizio, who are going to talk about have a deep dive on kubeadm details and talk in detail about HA deployments. So next up, the next layer of the pie above that, which is very common and probably the two keystone projects that are kind of core to SIG Cluster Lifecycle is Cluster API. So there's a bunch of reasons why Cluster API exists. And I wrote a long blog post that kind of outlines the philosophy and the history behind it. But it basically tries to answer a set of core questions. How do I provision other infrastructure that's associated with a cluster? Right? How do I manage the lifecycle events across that cluster in a declarative fashion? How do I manage a number of clusters in a similar way? Right? Because a lot of these tools that have been created don't actually work for N very well. Right? They work for one, but when you're trying to manage them for N, it starts to break down. The workflow becomes a little bit more difficult, especially if you're trying to do it in a declarative way. And how can you control it via an API?
And also, like, to add to that, we're not SIG multi-cluster, so we're not thinking about the layer above 15 clusters, but we're thinking about how is it possible to even, for an organization to even create 15 clusters.
Yeah. There's a bunch of logistics that come along with trying to actually manage clusters at that scale. If I had 100 clusters, there's like secure kubeconfig management, right, across all those clusters. There's a bunch of other details and logistics that go into management at that layer that Cluster API does not try to solve. It's out of scope. So as we mentioned earlier, Unix philosophy for life is that we want to make sure that each tool does that one layer and does it well. So there are tools that are trying to use Cluster API, and there are a bunch of ones that already exist today. COPS has an implementation that they're trying to push. KubeCon already does. There are multiple implementations from a bunch of different Kubernetes as a service providers. If you go to a Cluster API meeting, you will find that there are a bunch of people that either have implemented or are re-implementing something atop of Cluster API or like Cluster API. So if you look in the booths that exist out there, and if they have a Kubernetes as a service, odds are that they've implemented something that's akin to that.
And to add to that, like, this is the first alpha version.
Yes.
And they're already...
The keynote doors are now open. Please make your way to Hall 6, across the hallway door, 445 Suns.
Well,
We'll
thanks
speed this up.
everybody. Well, and yes, we have had a lot of people and companies already implementing Cluster API, although it's like it just hit in March its first alpha version, which tells something about the interest, but it also tells about the difficulty in finding some unity between all of these diverse tools.
Yes.
But that's why it's so important too.
Yeah. So it's going to take a little bit of time to find unity. Like we've learned, this is not new to us. We've dealt with this before in the past. Getting kubeadm to GA was a slog, right? And getting the community to get to that point where they actually had agreement and consensus took a while. But now we execute like a pretty finely tuned machine. So we're going to take that similar pattern that we learned before and we're going to apply it again, but it'll take a little bit of time.
And it will need contributions. It will need help.
Yeah, and it needs your help. So here's a little bit of an overview of sort of the schema for a deployment of a cluster. Right? You have your sort of machine deployment, and everything inside of Cluster API kind of mimics pods, right? So you have your deployments which have replica sets which have pods, right? In Cluster API land, you have machine deployments which have machine sets which have pods, or sorry, machines, right? So it's very analogous, it's one for one, they kind of match. So if you're used to Kubernetes feel of how you declare something, you just declare that same way inside of Cluster API. One thing we just had the nice long debate on the other day was that we finally got agreement from the entire community by force, was that is that we want to deal with immutable machine instances. So once you actually specify something, the actual instantiation of that machine is then immutable, much like a pod is immutable, right? So when you're dealing with it in that way, you don't have to deal with the management of your cluster in a immutable fashion, because that over time, if you're dealing with that across N, that becomes untenable. Imagine you have 17 sprinkle dusted, varied versions of clusters all throughout your empire. And everyone has like a slightly different version or incantation of software stack that you've managed to configure or install inside this. That is an untenable situation.
So instead, now you declare the decide state like this as a machine deployment, for example. Then you have an operator, well, Cluster API implementation, if you like, that creates. From the machine deployment, it creates machine sets, like a deployment creates replica sets, and the machine set controller creates machines. And this all, so far, is just like, can be written generically, because it's just talking to the Kubernetes API. But once you get to that we have the machine CRD, this is all custom resource definitions. Once we have the machine CRD, then it gets to the provider-specific place. So like, if I have my Raspberry Pis, I will have some kind of implementation to get a new machine. Or if I'm on AWS, I will talk to EC2. And that's the part. We're trying to have as little as possible, as little code as possible, that being the different parts of each cluster.
And if you want to know more, I highly recommend seeing, there's a talk on Thursday by Jason Tiberis and Hardik, who's from SAP. Jason works for VMware. And they have a deep dive going through the details of the current incantation, as well as talking about the roadmap for Cluster API for V1 Alpha 2.
Right. So this was about like trying to figure out everything on a whole cluster level. But we have a problem in like much smaller scale, which is each component is kind of all grown organically, of course, as time has passed. And now they're really different in how you configure them, how you set them up. Like there's absolutely no consistency in flag names. Flags are bad enough already. But then when you have 3 different namings of all 3 components for doing exactly the same thing, it kind of gets messy for operators, administrators. Then like today, even like there are many components that only do HTTP for whatever, like health checks and small round trip for metrics and that kind of stuff, and etc. And if you're like cluster API, and now as a cluster API implementation, I want to mimic the behavior of a Kubernetes component, I have actually a fairly hard time doing so. Like, I want to function as the API, so, well, that's not that straightforward. Or I want to function as the controller manager. That's not so easy as you maybe would expect it to. So that's why we started a workgroup component standard, which focuses on these two things, but also on components config that I said, like, managing with flags is not really viable over time. So then we're trying to do everything with declarative configuration. So next slide.
Yeah. So one thing just to touch on real quick is Cluster API doesn't solve the problem of reconf of individual components. Right? A lot of times when you deploy something, you want it to be immutable, but if you want to be able to reconf, you want to be able to actually manage the configuration on that cluster. Component figs, like primary function in my mind in the long-term schema of things, is to enable the reconf story. You deploy your cluster, but you probably made a mistake. There are hundreds of knobs. I guarantee you made a mistake. Like, you're probably going to take 5 times to think you got it right, and then 5 more times to actually get it right. Right? So then once you've gotten to that state, instead of you having to redeploy every single time, which isn't necessarily a bad idea, we want to enable the user story over time to be able to say, okay, just adjust the flag that's on the cluster using component config via well-defined type that's actually an API that lives on cluster that you can modify.
Exactly. So like, although we have cluster API, we need some way of actually telling the components what to do. And how do we actually, how do we make this happen? Like in kubeadm, we have this weird temporary workaround, which basically is like, we have a string map, a dictionary of that map, yeah, it's like it's funny, but maps the flag keys to the flag values, and that's just passed directly to the component, which is a terrible solution, but that's what we've got. So where we want to go is that we have versioned declarative configuration for each component. So then we can, even at the cluster API level, we can, like, when doing the whatever, we have a set of manifests in a Git repo, then we can have something deploy that to a cluster, deploy that to an environment in a totally, well, reproducible way. So as Tim said, like, I can deploy this actually to multiple environments now that I have the specification of how the controller managers should work or how the kubelet should do its thing. And this all also depends on component config. So first of all, using flag is not maintainable. Well, like, you do dash help on any component, and like, you will need to increase your terminal buffer. To like, or like print it to PDFs and like 50 pages. It doesn't work well on upgrades, because let's say we have some change in the defaults, or we have some we have a removal of a flag, for example, or we need, in some component, we need to add a new flag for it to have the same behavior or whatever. Then we're actually coupling the binary upgrade with the configuration upgrade, which makes it really hard to operate. But if we could decouple these and first upgrade the binary, and then afterwards we just reconf using the new API schema when things have changed, then it's totally a different story. Programmability. Many users want to, like, patch different things in, like, keep the default value for 90% of the things, and then patch some slight things for the business to allow them add business value for something. That's totally configurable. That you can do that easily with the kind of JSON resources we have in Kubernetes applications today, using customize or something similar, but you have no way of doing this really with flags. But also, like, you're really limited to key value pairs. Like, there's no way you can express all the things you could with a real object. And you have no API definitions or schemas. So what it will look like is the following. For example, Like you set API version, component.config.case.io. You give it the version. This version can be upgraded over time as the component evolves and the configuration alongside it evolves. But still, although you upgrade to a component that supports V2, you can still use the V1 schema to give it, and it will upgrade internally, map these things.
So as we mentioned, a primary function of like the developer track is to get people involved, to get you, the community, to give feedback, right? And involvement doesn't just mean contributing code. It means contributing documentation, contributing your user stories, contributing your, what went up in flames for you, and to give us feedback, right? So how can you get involved? Well, currently there's like hundreds of contributors across several companies, as you mentioned earlier. And we're working on growing our contributor and reviewer pool. Every single cycle in SIG Cluster Lifecycle, we try to do a good job of promoting the people who have chopped the wood and carried the water. Right? You, as I mentioned before, you earn your stripes by doing the hard work. And if you show up, if you help out, we will absolutely promote you inside there to be a reviewer, a member, an approver, or reviewer, depending upon where your level's at. And the SIG chairs often, and approvers, often go through this every single cycle. We have a conversation about it. And for folks, there's a bunch of EMEA contributors who are very active. So, there are definitely people here in your local time zones to actually help you out.
Right. So we have, well, whatever. We have had a new contributor onboarding session, which is available on YouTube, where we basically went through the different things along with new people answered a lot of questions, so forth. We're gonna schedule one more of those pretty soon, I guess. Mm-hmm. We haven't set a date yet, but the one that has already been is up on YouTube, and you can look out for the new one pretty soon. There's different labels, so we have like an issue backlog for every sub-project. So every sub-project has its own repository in GitHub in either the Kubernetes organization or the Kubernetes SIGs organization. And there, look out for the labels, good first issue, help wanted, or SIG Cluster Lifecycle in the main repo where we need to determine who it belongs to.
There's a regular Zoom meetings that we have. So I've seen certain faces here like every week for like the last years of my life. I know like wrinkles on Fabrizio's face. I know how Lucas's hair looks. And we've talked to each other all the time. So like getting to see them face to face is actually kind of nice, right? And we get to know each other and share and swap stories as well as work on code together. So it's often a great way to develop rapport with people all over the planet. And we communicate in Slack all the time. I kind of wish Lubomir would sleep more. So like when I'm typing things on Slack, he would be asleep, right? But it's a great community to be involved in. People are very passionate about this space. People have been very passionate about SIG Cluster Lifecycle because they want to make it better. We want to avoid for lack of a better term, we want to avoid the tragedy of the commons that exist in a lot of other open source projects. And people are doing their level best to try and make this happen. Over time, with enough people, enough effort, it's definitely going to work.
Yeah, and well, as we said, like we have contributors, and we have some contributors, and we have some kind of plan where to go. But we definitely don't have enough staffing on the different projects. For example, component config is really understaffed. Like just like before this, I was talking to one of the other leads of that group, and we're trying to find a way to find more people that could actually help out with coding, because like doing the conversion from flags to declarative configuration is not easy. But it obviously is in many other parts too, like both easier tasks and harder tasks to begin with.
Yeah, and there's plenty of people to help you get involved. I want to thank Fabrizio for this slide because he kind of put it together, but it gives you kind of a mental model of where the different life cycle lives across the different projects. with kubeadm being the most mature currently, as well as some of the provisioning tools that exist out in the wild. There's other logistics. Again, I mentioned we have Slack channels. There are separate guides that we have and documentation. There's a ton of information. These slides will be publicly available with all the links and accoutrements, so you can click on all the links later on. If you want to get involved, just reach out to us, and we'll try to hook you up and get you involved. Last but not least, there's other SIG Cluster Lifecycle talks this week. There's the kubeadm deep dive, Cluster API deep dive, Kops deep dive, and Kube Spray deep dive, and that's pretty much it.
Do we have time for questions, or is it out of time?
Sure.
Okay. Cool. Yes, but for the recording. Okay. Okay. Well, I'll repeat it. Yeah. Please.
It's
cases of the cluster lifecycle technologies
Right.
with regard to the existing systems that are vendor specific and probably are competing with
I'll repeat the question. So the question was roughly that what is the relationship between the vendor solutions that are out there in the sponsor area and the projects, end-to-end projects that we are creating, for example, Kops and Cubes, right?
Yeah. So in the fullness of time, the cost of owning a Kubernetes cluster should be zero, right? So, and GKE actually promises this already. So the cost of maintaining a GKE cluster or getting it up and running is zero for a cluster of up to 0 to 100. So that's an average. So by doing this, we're trying to make it easy and ubiquitous. So again, if you want to have a core that is strong and will last a long time, and that everyone can depend upon, we need to make sure that it's ubiquitous. So the purpose of these tools is not necessarily to supplant the existing ones, but to provide ubiquity and a story that exists for everyone else. Not everyone can use GKE because there might be constraints, legal restrictions, or other security restrictions that you might have for your on-premises environment or whatnot. But so we want to have a story that allows them to use these tools that exist there in the community.
And also, just because we have some projects doing nearly similar things as like 90 vendors, doesn't mean that any companies have to choose our solutions or like not use vendors. Like, it doesn't mean that we're competing with vendors. Instead, more maybe exchanging ideas, testing out, prototyping things, and like providing alternatives which you don't have to pay for. You don't have to sign legal agreements to start using a Kubernetes cluster. Instead, that actually works.
Just to add one more bullet point, if you go to a lot of the vendors are actually using core technologies that have actually been developed by SIG Cluster Lifecycle. So like if you look out there on the landscape, most of them actually are using some piece of the puzzle that we've helped create.
Yeah, so many, like we said, kubeadm is built to be used by all of these vendors, and many of them do. And many of them also like use Cluster API and that kind of stuff. So we want to integrate and to actually to ease the load of vendors so that the vendors can actually like focus on the stuff that on top and focus their time that they do focus on cluster deployment, contribute to us so that it benefits everybody. So what I said in the keynote this morning was like when you do contribute to the Kubernetes community instead of your own product, your contributions have multiplied impact across all, like every Kubernetes cluster ever created. So that's totally different things versus your own.
We are out of time, but we can actually answer questions afterwards. So I want to thank you everybody for coming.
Thanks.